Okay, moving on to this next segment. Right? Now we're going to be talking about the number of solutions. Okay, so recall that the discriminant, let's write this down, y equals to a squared plus ax squared. 8x squared plus bx plus c. The discriminant is equal to b squared minus 4ac, which uses this b here and this c there. That is a test that allows us to work out how many solutions there are. Well, now this is that same case, but in the graphical context. Okay, so how many solutions is the same as saying how many x-intercepts, because an x-intercept is a solution. Remember, when discriminant is less than 0, there are no solutions, which means no x-intercept. So for your function, it's either all above if it's positive and all below if it's negative. Okay, this is the graphical interpretation. Discriminant equals 0 means one solution, which means one intercept. So we call this touching. Okay, again, all above, sorry, not all above, positive touches there at the turning point, but it's concaving up, or negative touches there at the turning point as well. And we call this, and this is concaving down. Right, so one x-axis intercept, not only does it tell you that there's one solution, it's also saying that solution is a turning point. Okay, the turning point is sitting on the x-axis. TP on x-axis. Right. And then finally, two solutions where discriminant is greater than 0. We call this crossing. So you have concaving up, concaving down. The one that concaves up here crosses the x-axis at 2 points, or if it concaves down, same thing applies, crosses the x-axis at 2 distinct points. So use the discriminant not only to check the number of solutions, but also the number of x-intercepts. So let's have a look at, we'll have a look at this next example here. This next example is a little bit trickier. Show that the equation x squared plus a plus 1x plus a minus 2 has two distinct solutions. This thing here and this thing here, this a, we don't know what it is. It's just some random value. Okay, it's just some constant. We need to show that this quadratic has two distinct solutions, which means what? This quadratic has to look like this. We need to show that it looks like this with two solutions. What this means is you have to show that the discriminant is greater than 0. This is the key, right? You need to show this. So to show this, let's start with the discriminant. Okay, discriminant is equal to ax squared plus bx plus c. B squared minus 4ac. B in this case is this whole thing here, a plus 1. Okay, because that entire a plus 1 is the coefficient of x. So a plus 1 minus 4 times a, which is 1, times c, which is a minus 2. Okay, so this is your discriminant by the formula of b squared minus 4ac. What we're going to do here is to expand everything. So it's a squared plus 2a plus 1 minus 4a plus 8 minus 4a plus 8. Giving us a squared plus 2a minus 4a minus 2a plus 9. So the discriminant itself is also a quadratic. What you need to somehow show is that this quadratic is greater than 0. There's a couple of things you can do here. A more advanced method would be to use another discriminant on this discriminant, because this discriminant itself is a quadratic, right? But I think a more straightforward one, okay, would be like, how do I make sure this is a positive? Okay, have a look at this maneuver, this manipulative step here. So a squared minus 2a, I'm going to rewrite this as minus 2a plus 1 plus 8. Okay, so I'm completing the square, actually. I've split 9 up into 1 and 8, so I'm not changing the value. But why did I do that? It's because now I've got a squared minus 2a plus 1. What's this? Let's go here. What is this? Simplify to? A squared minus 2a plus 1 is a minus 1 squared. Exactly. A minus 1 squared plus 8. This is my discriminant right now. My discriminant is a plus 1 squared plus 8. How do I show that this is positive? Think about what's happening here. You have a plus 8, which is positive. You have a squared term. What's the smallest value the squared term can ever be? Can the squared term ever be negative? No, right? You're squaring a minus 1. Whatever a minus 1 is, after you square it, it's not going to be negative. The smallest value that it can be is what? Possibly 0, right? A, for example, equals to 1, then a minus 1 squared is equal to 0. 0, on top of that, you add 8. Will this whole thing ever be negative? Nope. Right? So you got a positive a minus 1 squared. You got a positive 8, which is added on. Okay? So you know that this is always positive. How do you show that? A minus 1 squared is always greater than 0. So greater than or equal to 0. This is fine. You're saying something squared will always be greater than or equal to 0. Therefore, a minus 1 squared plus 8 will always be greater than or equal to 8. Now you add 8 on top of that, they'll always be greater than or equal to 8. What's great? If this satisfies being greater than or equal to 8, it satisfies this condition, right? Therefore, discriminant is always bigger than 0. Okay. This is one way of proving that your discriminant is always going to be a positive value. If your discriminant is a positive value, then this thing has two distinct solutions. Two solutions.
拿到其他的难吗？